Hello. Welcome everyone. Am I audible? Okay, nice. So, let's begin. So, we will be solving some problems today using the concepts that we have learned till now, and the problems won't be too hard. So, let's try and solve them. So, the first problem is frog 1. You can also try to submit these problems. They are all from AtCoder DP contest. So the first problem is frog 1. So the problem is simple. There are n stones numbered from 1 to n, and for each I 1 to n, the height of a stone I is hi. There is a frog who is initially on stone 1. He will repeat the following action some number of times to reach stone n. If the frog is currently on stone I, jump to stone I plus 1 or stone I plus 2. Here, the cost of jumping is absolute value of the difference of the height, where we take the difference from current to the stone we jump on. You have to find the minimum possible total cost incurred before the frog reaches stone n. Okay, so the constraints are n is 25, h is 24. Okay, that's all. So let's look at the problem once and then I will give everyone time to think. Okay, so the problem is straightforward that we have an array of heights and different heights are there, and a frog is jumping initially on stone 1, and they can jump one step forward or two step forward at a time and give the cost of difference of height. So what is the minimum height that we can get? Okay, so I will give you a few minutes to think and then we will discuss the approaches. Okay, so let's discuss. So this is pretty straightforward. Obviously, there are a lot of ways in exponential time of 2 to the power n or many other ways in which you brute every possible jump you can make, but we can obviously see that if we want to calculate for any, yeah, so Aditya is quite correct that we can simply just check the cost of find the minimum cost of coming to a stone by checking the previous two stones, and that's all. Okay, so let's write let's look at the code for this problem. So the code is straightforward. We will take input n and we will take input the heights of all the stones, and then we can, what I have done is I have created an extra index of height 1e9 before the stone 1, so that I don't have to write much if else. And then it's straightforward that I have assigned the cost. I have added a new stone 0, and no cost of reaching stone 1 is 0, and cost of stone 0 is not important because it can never be the best answer because the height difference will be huge. So this is irrelevant, we can put this any value. So for I just have to run a loop for 2 to n, that the answer of I will be minimum of these two values, jumping from one stone behind it or two stones behind it. So pretty straightforward, and the final we have to print the minimum value final stone. Okay, so this will be open. Okay, now let's look at frog 2. So the question is same, just the difference is that we can now, instead of 2, we can jump k steps forward. And the question is exactly the same. The constraints are that n and h, for n and h the constraints are same, and k is 100 at max. So it's the same problem, and if you want, you can think for some time, and if you have any approaches, please do share them in the chat. Yeah, so I think we should discuss, as this is also literally the same thing, just instead for checking one stone behind, we will check k stone behind, and as n into k, for every stone we will check k stone behind, and as n into k is 1e7, think that will pass. Okay, so let's look at the code. So it's quite straightforward. We have just taken input n. Now instead of adding one extra stone, I have added k minus one extra stone behind it, and I have taken the input and I have set their height as very big so that they are never the answer. And then I have simply initialized the cost as 1e9 for all the stones, because uh, I know in the worst case the cost will be less than equal to 1e9, because, like, let's imagine an impossible case that I jump, for every jump I pay 1e4, then also my cost will be less than 1e9. So 1e9 cost is impossible, so hence I have put initialized all the costs as 1e9, and then I just simply have to check the cost for each stone, and for checking the cost of each stone I have to check the cost of stones, k stones behind it. So that is the code, and the final index is the answer. Okay, pretty straightforward till now. It will be done in n into k. Okay, now let's look at another question, vacation. So the problem is that Taro's summer vacation starts tomorrow and he has decided to make plans for it. The vacation consists of n days. For each I, 1 to n, Taro will choose one of the following activities and do it on the ith day. Swim in the sea, gain AI points. Catch bugs, gain BI points. Do homework, gain CI points. Nice. As Taro gets bored easily, he cannot do the same activities for 2 or more days consecutively. Nice. Find the maximum possible total points of happiness that he can gain. Okay, so the points are given. The points are per activity per day. So we have 3 endpoints and we have to find the maximum total points. Okay, so the constraints are n is 1e5 and aibici is 1e4. Okay, so let's just look at the problem. So, okay, so the problem is again straightforward. So there are n days in my vacation, and for every n day, I every day I am given a value of a, b, and c. I need to choose one value for each day, and it is necessary that on 2 consecutive days I don't choose the value from the same array. So what is the maximum answer I can get? Okay, so yeah, you can think for some time. Hmm, so we can take the sum of two higher values of ABC to be x. Aditya, can you please elaborate a bit? Can you elaborate a bit more on what exactly are you proposing? Mhm. If mm, I think if I understand you correctly, what you are saying is that out of these three, we will take the two highest values, and similarly, out of these three, we will take the two highest values, and so on and so forth. And then, using those values, we can build a solution that if uh, I was ending on this value, then what will be my answer? If I was ending on this value, what will be my answer? So on and so forth. I think, yeah, this will be correct, as like we can always prove that every time we will be choosing two of the higher values, and we will never be choosing the no, wait a second, just a second. No, yeah, sorry, yeah, we cannot actually prove that, sadly. So there is an edge case, I think. Yeah, so yeah, this is the edge case, I believe. Like, this is just hypothetical, it might be out of constraints. Like, okay, I will just put it in constraint. Okay, so yeah, for this case, I believe this will fail, as if you will take just the two higher values every time, you can at most get the answer as 1101, but the most possible answer is 2001. So yeah, we have to, it is possible to take the lowest. Okay, so yeah, so okay, now let's discuss the solution. So yeah, your idea was pretty close, but instead of taking the two highest values, actually we have to take the three highest values, and we only have three values, so we will take all of them. Why do we have to take the three highest values? Because we can prove that only three highest will be used, as suppose, by contradiction, suppose I'm not using the third highest of the values, then I can simply go in at least one of them, because at most two of them will be cancelled from left and right. Okay, so all that being said, let's look at the complete answer. So the complete answer will be that I can just store what is my maximum answer at ith position if I end in A, or if I end in B, or if I end in C, and then using this information I can calculate the same for I plus 1, because the best answer for ending in A will either come from this or this. Similarly, for B will either come from this or this, and C will either come from this or this. So taking these values, I can simply keep on creating a DP of 3 into n, and the last state of that DP will tell me the answer. So let's look at the code once. Okay, so I have initial, actually in this DP of 3 into n, I don't need to store this, because once this value has been used, it's no more useful. So I just have to maintain the current three variables and make the next three using these. So yeah, so I have simply initialized to them to 0, because initially the score will be 0. Then I have taken the input for the score of the 3 days and the next day, and then I can just say that these three values will be x, the value of A will, I will add that the max of value of B or C, similarly for B A and C, and C A and B, and then finally the final answer will be the max of these three values. So that's all. It will be done in 3n, so O of n will be the time complexity. Okay, now let's move on to some interesting problems. We have learned knapsack, so let's try the question knapsack 1. The question is standard knapsack, that there are n items numbered 1 to n, and each item has weight wi and value vi. I have a maximum capacity of w, so what is the maximum sum of values that I can take with me? Constraints are straightforward, that I have 100 items, the maximum weight I can take is 1e5 of the order 1e5. All the weights are less than the maximum weight, and values are of the order 1e9. Okay, so let's look at the question again. Okay, so let's look at the question. The question is straightforward. I have some weights. These uh, these weights have some values with them. I have a knapsack. It has a maximum capacity. What is the maximum value that I can take with me? If you guys want to think and tell the answer, it will be fun. I think the answer is pretty obvious as we have already seen knapsack. Okay, so I know that the maximum weight is limited, so I can make an array of weights and storing what maximum value I can make with this weight, and then I can simply iterate over the knapsack. And suppose I have some value, I have some weight. Uh, Suppose I have some weight with some value v. I can say that with this new weight wi, I can make w plus wi with value v plus vi, and over here I can put the maximum of these two values. Similarly, at the end we will check what is the maximum we ever gained, and that will be our answer. So it's very straightforward, knapsack, and that's the solution. We have taken number of items, maximum weight, and we have created what is the maximum possible value for each weight, initialized all to 0. Then we have taken the items. For each item we are iterating over the array. The important thing is we are iterating in reverse so that we don't mistakenly take an item twice. And then finally we take the max of the array and report it. It will be n into w, and as n into w is 107, it will pass. Okay, now knapsack 2. The question is exactly the same, only the constraints are different. The constraints now are that weights, total weight can be 109, and but the value of each item can be 1000 only. Okay, so now we know that this approach won't work as we cannot iterate over w items, so n into w won't pass at all. So what will be the answer in these constraints? You can think for some time. Okay, I think we should discuss it. So this is also quite straightforward, and the hint is in the value. The values are less because the value is 1000. The maximum possible value we can get is n into 1000, which is n into 100 into 1000, i.e. 1e5, which I can iterate over. So what I can say is that I have made an knapsack where each index represents what is the minimum weight that I can make with the value of the current index. So for first index, suppose I have 3, so to make value 1 I need minimum weight 3. For suppose for index 4 the weight is 7, so for 4 the minimum weight I require is 7. And in this we can work in a similar fashion, that initially I will initialize all the weights to an impossible infinite weight, and then I will just say that suppose this is possible, so using this I can say that uh, suppose the value of our weight is 9, so I can say 13 can be, and the value weight is 10, so I can say that 13 can be made with 17 weight. So this will run in n into v into n, so which is 27, so it should work. So let's look at the code. So I have set the maximum possible value to 25 plus 10, taking some margin. I've taken input and maximum allowed weight, and I've taken initialized the weight array, which is the minimum weight to reach a certain value. And we know we have initialized it to 1e9 plus 7, 1e9 plus 1, because any weight above 1e9 will always be pointless as that will not be taken. So I have simply said that minimum weight to make value 0 is obviously 0. Then I'm iterating over the values. In a similar fashion, I'm iterating in reverse so that I don't take any value twice. And finally, I will check for all values for which my weight, minimum weight possible, is less than the capacity, less than equal to. I can take that and I get the max out of all those, and that is my answer. Okay, so it will be n into n into v, quite straightforward. Okay, now let's look at a new problem, coins. So there are we have a positive odd number n, and there are n coins numbered 1 to n. So for each I 1 to n, when coin I is tossed, it comes up heads with probability pi and tails with probability 1 minus pi. So Taro has tossed all the n coins, find the probability of having more heads than tails. Okay, okay. So for every toss, the probability is different, and we have to calculate the probability of getting more heads than tails. So n is 3000, which is 2999 is n is odd, and probability is 1 to p. It's a decimal number, and oh, that must be a typo. Okay, so let's ignore it. Okay, so the question is that I have n coins of the order 3000 of 3 maximum 3000, and for each they are the probability of heads is given, and what I need to find is, if I toss all of them, what is the probability that I get more heads than tails? One number will be more always, so I have to calculate the probability of that. Okay, so what I can do in this question, I will give you some time to think. Okay, so let's discuss. So one thing is pretty obvious and straightforward, which is, which we can see is, suppose that we know what is the probability till the ith coin that we have x heads. Then we can say that this will contribute to x plus 1 heads with the probability of this value into pi. Also, we can say that the probability of x plus 1 heads was u. This will also contribute here with the probability of 1 minus pi into v into u. So we can say that we can say that for any state, the probability of getting that many, suppose x heads, suppose x heads till ith coin is tossed, will be pi into x minus 1 I minus 1 plus 1 minus pi into x I minus 1. So for every state, it seems that I can calculate xi if I have all xi of the previous state. And luckily we can do that, as x will be of the order n and there are n elements, so this will run in n square time, which is possible. So let's look at the code. So I've taken input and I have initialized the probability of all things as 0. Then I've initialized of having 0 heads at initially having 0 heads as 0, as 0 heads as 1, because that will be the initial condition. Okay, then for every state I can simply say that Pij is Pi minus 1j into 1 minus P, which is Pp, and Pi minus 1 Ji minus 1 into P. We obviously cannot do this if we obviously cannot perform this step if j is 0, so that we have done separately, and then we finally get the answer. Okay, so it's n square. Very nice. Okay, so now let's discuss this new problem, stones. So we have a set A which has some values, n positive values. Taro and Zero will play a game with each other. Initially, the pile has k stones, and the two players will perform this operation alternatively, starting with Taro. So choose an index x in A and remove exactly x stones from the pile. So we can do current stones minus a1 or current stones minus a2 till so on till minus an. We can choose any of it. A player loses when he becomes unable to play, i.e., there is no way that they can remove the stones exactly, choose a value from A and remove exactly that many stones. Assuming that both players play optimally, determine the winner. Okay, so let's also look at constraints. N is 100, K is 25, all the values are less than equal to K. Okay, so what is the question? So this question, first of all, obviously involves some game theory, as first of all we have to think what the two players will do, what the two players will want, so on and so forth. So we have this question of k stones, set a1, 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 a2, so on till an, and what we have to determine, we have to find the winner. Okay, so I'll give you some time to think. Okay, so uh, this at first glance seems like a very hard problem, but we can solve this uh, if we apply dp. Okay, so at the first glance, it seems quite random and weird that what will happen if I will remove some stone, or what will happen. So in this case, we can start imagining from the base case, i.e., if there are zero stones left, then obviously whoever's turn is it is the loser. So zero stones is a losing position. Now, similarly, I can check for one, that is one a winning position or not, by removing stones from one and check if I can force my opponent to go in a losing position. And I can repeat this process for every player, so every number of stones, so on. So for example, my set was 2 comma 3 and I need to check the answer for 4. So I will simply go minus 2, which is 2, or minus 3, which is 1, and check if any of them is the losing position. If they are, then I will make that move and force my opponent to lose, and make this a winning position. If there are no losing positions, then I will have to make a move which will make my opponent win. So this will be a losing position. So yeah, now it's very straightforward, n into k. So let's look at the code. So the code will be very small. We take nk input, and we may take a input, and we initialize, first of all, assume that all positions are losing positions. Then uh, we find the answer for each position, then we iterate over a. Basically, we are trying to find a position which we can force our opponent into, that is also a losing, that is a losing position, that will make this current position a winning position. So I will iterate over all a. If I will find a position that is a losing position, that will make this a winning position, and at the end we will check if k is a winning position or a losing position to determine who will win. So this will run n into k. Okay, just 1 second. Yeah, okay, so we are at the final problem for the day, and let's look at it. It's matching. It's a very fun problem. Okay, so there are n men and n women, both numbered 1 to n. For each ij 1 to n, the compatibility of man I and woman j is given as integer aij. If aij is 1, man I, woman j are compatible. If it's 0, they are not. Taro is trying to make n pairs, okay, each consisting of a man and a woman who are compatible. Here, each man and each woman must belong to exactly one pair. Find the number of ways in which Taro can make n pairs. Constraints: n is 21, aij is either 0 or 1. Okay, so let me explain and elaborate this question. So it's a fun question. So what I'm saying is that I'm given an n cross n matrix of zeros and ones, which tells me, which basically tells me what is, which basically tells me what if the ith woman likes the jth man, basically they are compatible or not. Okay, now I need to make n pairs. Basically every person should be paired with exactly one person whom they are compatible with. Now, how many ways I can do this is my question. So if you want, you can think for some time. Okay, so let's look at a solution for this problem. So this, at first glance, this does not, the answer is not obvious. So what we can do is we can try by thinking what are our options. So first of all, one obvious option is doing n factorial. Check every possibility. If it is possible, then we can add n fa if it is possible, then we can add it to our answer. So this will obviously not run, as 21 factorial is very big. What else we can do? What we observe is that we observe that if I know the answer of a subset of people, of subset of men, for example, I know, uh, first of all, I am representing it as uh, a number where 1 represents that I took the ith man and 0 represents I did not took the ith man. Similarly, I can do for women also. Suppose I am making this pair and I am saying that I took these men and these women, and I am asking in how many ways I can pair them up. Then I can answer this question easily by assuming that this man was paired, will be paired with someone. So I can just assume that this was paired with this or this or this or this. When this was done, I can add the answers of all those possibilities and get the answer for this pairing. So how can I add those answers? To add those answers, I can say that let's assume these two were paired, then I can simply remove them from my number and check the answer for 1011 paired with 1110 and add that to the answer, and similarly I can repeat this process. So I will get the answer for every number in O of n, and the total possibilities are 2 to the power n into 2 to the power, actually it's not exactly this because every number will not be paired with every number, they will only be paired with the matching digits. So yeah, we can calculate and try and calculate that complexity. So it will actually be nc1 whole square plus nc2 whole square so on and so forth till ncn whole square, and these many pairings will be there, and I can calculate the answer in this time complexity, and then I just have to check the answer for all ones with all ones, and that will be my final answer. But as we can see, this number is pretty huge, so it won't run. We can even calculate this for as n is small, we can just brute force calculate it. uh, if you want I can show you, but this number will be pretty big, so this will not run. But uh, this gives us an interesting observation. This gives us some transitions that we can use. If we use this observation that all making all pair of men, all subsets or combinations of men is actually wasteful. What we can say is that because we just need the answer for the complete set, what I can say is that I will first of all solve uh, yeah, what I will say is that I will keep on adding men, and I will only calculate the answer of the, the new state using this new man. So, in essence, what we are saying is that instead of going over all the possibilities, we can simply just keep on adding men in order and check their combination with all the subset of women of the same size with same number of ones. Basically what we did was, in both, in the first approach, on both sides we were taking all possible subsets, but now we will simply be taking, on one side will be consecutive ones of some length, and on the other side will be all possible subsets of that length, that number of unset. Now why it is correct is, I can state it in a another way, which is that what I'm actually doing is I am calculating what, in how many ways can exactly these men be paired, and using it we can calculate in how many ways exactly these men can be paired, and so on and so forth. We were able to do this because what we require at the end is pairing of all men and all women. So we can insert men at one by one. Like, is this clear? Or should I elaborate it more in depth? Like how we reduce 2 to the power n into n. Okay, so let's move on. Okay, so uh, using all these observations, two solutions become evident. Let's discuss them one by one. The first solution is I add men one by one, which is that I first of all calculate number of ways to pair for all the women with one first man added, then I do it for the second man also added, third man also added, so on and so forth. I can do this, as I've already shown, I can do this because whenever I want to find how, in how many ways some subset of women can be paired with these men, I just simply have to pair this man with someone, and then I can calculate the rest of the answer and find it. So the time complexity of this will be 2 to the power n for all the subsets into n, because we will pair this man with every woman that is possible, and into n for every man. As n is 21, this is approximately 48, so this can pass. But if we make just one more careful observation, we can say that this number need not be 2 to the power n, which is that because we just need the answer of two complete sets, we can say that we will only be pairing, suppose let's say 5 men with 5 women only, and any other pair will not contribute to the answer. So what we can say is that instead of keeping it 2 to the power n, we will only keep it uh, of the size of elements which are of the same, which have the same number of ones as our current number of men. So instead of this term being 2 to the power n into n, this will whole be just 2 to the power n, because every number in 2 to the power n will only come once. So we will be able to remove the n from it. So what our final solution becomes is that I will keep on adding men one by one, and I will calculate for all subsets of women what, let's assume, for example, if I was doing it for 3 men, so I will write it for all subsets. Yeah, for all subsets of women, I will calculate how many ways there are for these 3 men to be paired with all the subsets of women. For each subset, how many ways there are, and similarly I can keep on moving forward, and at the end I will just have to check for all men versus all women, and that will be my answer. So let's look at the code. So the code is simple for this as well. So we take the number of men and women, we make capital N as 2 to the power of n for simple use. Then we take input, we make an array, because we are not storing it in 2D array for faster implementation, because every number is a bool, so we can just store it in an integer, and we can, to make it one, we can or it with the number. Okay, so we have made a DP. So this DP represents the number of ways of the number of ways we can make a pair. So what I'm going to do is I'm simply going to iterate over all the subsets, because n is 2 to the power of n. All the subsets will be iterated in this way, and then I will check for how many ones are set in it, because with this I can tell with which man this subset of women will be paired. So uh, then I will iterate one by one, iterate over all the set bits in V, and remove that bit and add the answer after removing that bit, and finally I will take mod and get the answer. So over here we have done AND with AB minus 1, because we actually have to check also if they are valid pairings or not. So simply the AND should be 1, because if it is a valid pair for the bth man, then their number would have come in AB minus 1. So even though it looks very complicated to implement, we can directly do it by using this. That's all. If you have any doubts, please do tell. So if there are no doubts, we can end it. Please do approach us on Discord if you have any further doubts.